Oh, hey, you made it. Thanks for stopping by. You want me to talk about sound intensity? Sure. That was pretty lame. I'm trying to be funny, but I can't. So I'm just going to talk about sound intensity and the decibel scale. Uh, we've done a lot with frequencies, but to talk about the amplitude or how loud a sound is, we have something called sound intensity, and the intensity is just a measure of the power of a source divided by the area that that sound is spread over. And this picture right here shows a sound source, what we call a point source, and the sound radiates outward in all directions. And if you spread that sound over a small area, then it's pretty intense, but if you spread it over a larger area, then it's not going to be as intense. And we know that the farther away you get from a speaker, the less intense the sound is. What we're going to use for a point source, the intensity, the equation we're going to use is the power divided by 4 pi r squared, where r is the distance away from the sound source and p is the power. And if we look at the units are the units of power, which are watts, and the lower part, the denominator, is the units of area, which are meters squared. So we write watts per meter squared. So those are the units of sound intensity. There's two really important sound intensity values that we look at. One is called the threshold of hearing. This is the softest sound that the human ear can detect at about 1 kilohertz. And this number is symbolized by the variable I-O, and it equals 1 times 10 to the negative 12 watts per meter squared. You can see that it's a very small number, but most sound intensities are very small numbers. They rarely go over 1. So this is the threshold of hearing. This is like a pin dropping, you could say. A very loud sound would be something that approaches what we call the threshold of pain, where sound becomes uncomfortably loud. And this threshold of pain has a value of 1 watt per meter squared. So if you look at these two values, the threshold of hearing, soft sounds, and the threshold of pain, loud sounds, you can see that they're very far apart, 12 orders of magnitude apart, essentially, 10 to the negative 12, and then just 1. So because there's such a range of sound intensities, we have what's called the decibel scale that kind of consolidates things. So decibels are also known as sound intensity level. So when you talk about sound intensity levels, you talk about the decibel scale. And the decibel scale is a logarithmic scale. And what that means is that every time you go up 10 on the decibel scale, something is 10 times the intensity. So for instance, a machine shop, like our wood shop, if we were to have 10 of those, then that would be what a rock band concert sounds like. So a concert is at 110 decibels, a machine shop is at 100 decibels. A concert or rock band with the amplifiers is 10 times the intensity of a machine shop. If we look at a jackhammer or a pneumatic drill, that's at 120 decibels, which also happens to be the threshold of pain. That is 100 times louder than a wood shop or a machine shop, because we go 10 times to 110 and then another 10 times to 120. So every time you jump up 10 on the decibel scale, it's 10 times the intensity of the previous thing. The way to calculate decibels that we're going to use is 10 times the log of I over I-O, where I is the intensity of the sound that you're listening to, and I-O is the threshold of hearing. The units for decibels are simply D, capital B. And this B for decibels, well, we just put like a little tail on the B there. So I wanted to do an example solving the equation. If the decibel level were 83 decibels, what is the intensity of that sound? So I have to solve the decibel equation. I'm going to write that out right here. And to do this, I'm first going to divide by 10. And then to get rid of the log, I have to raise both sides to 10 to the power. So that's going to be I. And then I'm going to multiply both sides by I-O. Made a mistake there. 10 raised to the V divided by 10 power, and that equals I. Then I can plug in the numbers. So 1 times 10 to the negative 12 times 10 to the 83 divided by 10 power, and that equals I. And I'm going to look at my notes for a minute here. I think it's 1.995 times 10 to the negative 4 watts per meter squared. So just to sum things up, sound intensity is how loud something is. It's measured in watts per meter squared. And we use the equation I equals P divided by 4pi r squared. Sound intensity level is the decibel scale. It's how loud something is compared to something else. So that's measured in decibels. It's a comparison, and the key word is level. That's how you tell the two apart. And decibels is 10 log I over IO. So there's a brief introduction to sound intensity and sound intensity level, aka decibels. And you should try the questions out. And I'm going to go over most of these things tomorrow in class if you have any questions. All right, thanks.